Good afternoon, guys. My topic this afternoon is integration under partial fractions, still under case number 2, repeated linear factors. Repeated linear factors, integration under partial fraction. Okay, let us do the work today. Integration by partial fraction under case repeated linear factors. Okay, I will just give you one example today, but it's a good example. It's a brief solution, but I will give you the shortest possible explanation to it, so there will be no boring time. Okay, guys? The integral of dx over x cubed plus x squared. Dx over x cubed plus x squared. Okay, let's bring out the solution. X cubed plus x squared, it can be written as the product of x times the quantity x plus 1. If we expand this one, what will come out is x cubed plus x squared. If you try to notice it, this is a linear factor, this is a linear factor, and it is repeated, right? Linear factor x plus 1, it's not repeated. So for the meantime, the given problem is a combination of a repeated linear factor and not a repeated linear factor. And the other one is not a repeated linear factor. X can be written as simply x minus 0, right? The other x is actually x minus 0. The third linear factor is actually x plus 1. Same linear factor, and it is repeated. Linear factor, but it is not repeated. So if we try to bring out the equivalent of this, this one. 1 over x cubed plus x squared equal to, there will be three partial fractions. For the repeated linear factor, first one will be a over x. Second one will be b over x squared. We stop here because the power of the repeated linear factor is, the highest factor is only 2, so we stop at 2. Okay? This linear factor here is represented by c over x plus 1. Okay? This portion is the repeated linear factor. This is not repeated. Okay? So the equivalent is actually a over x plus b over x squared. We stop at 2 because the highest power is just only 2 for the repeated linear factor. Okay, let's try to simplify. We multiply all the terms by x times x times x plus 1. Okay. The right hand side multiplied by this will cancel out totally. So the left hand side will be 1. For the right hand side, for a, 1x will be removed. So 1x will be removed, so what will remain as a multiplier for a will be x times x plus 1. This is x times x plus 1. Okay? For b, this x square here will be removed. So the multiplier for b is only x plus 1, quantity x plus 1. For c, okay, if we try to multiply c by over this times this, x plus 1 will cancel. So the remaining multiplier for c will just be simply x times x times x. And if we are to expand this one, algebra, 1 is equal to ex squared plus ex plus bx plus b plus cx squared. This is the product of a times this. This is the product of b times x plus 1. And this is cx squared. This is cx squared. Okay. To compute for the values of a, b, and c, we'll do this one. Equating coefficient of like terms. Start with x squared. For x squared, left hand side will be 0. Right hand side will be a plus c. This is a, okay, and c. Equation number 1. For x to the first power, left hand side will be 0. Right hand side will be a plus b. A, and this is b. So 0 is equal to a plus b, equation number 2. Okay. Equating coefficients of x to the 0, meaning all constant to the left and all constant to the right. Constant to the left is actually 1. Okay, this one. Equal to the constant on the right, luckily, it is just simply b. It is this. B. And we now know the value of b. Therefore, b is equal to 1, right? Simple as that one. If we go back to equation number 2, we'll try to compute for a in terms of b. A is actually negative b. We transpose this one to the left and then we arrange. So a will be equal to negative b. Equal to negative open quantity. The value of b is actually 1. Therefore, the value of a is equal to minus 1. From equation number 1, try to compute for the value of c. C is actually equal to, we transpose this a here to the left, then we rearrange. Therefore, c is equal to negative a, negative open quantity, negative 1. Negative will be 1. Therefore, c is equal to 1. Okay? So, we now know the value of ABC. Therefore, the integral of dx over x cubed plus x squared equal to, I will try to raise up this one, you might not see it. Okay. We substitute the value of a, b, and c to be all 1, okay? Therefore, the integral of this will be a is negative 1 over x, plus b is actually 1 over x squared, plus the value of c over x plus 1, closed quantity dx. Then try to expand. Negative 1, we bring it out. The integral of dx over x, we put dx inside, plus the integral. This is x squared, we bring it up. This is x to the minus 2 dx, plus the integral. 1 over x plus 1 times dx, the integral of dx over x plus 1. And luckily, these are now all integrable. First one, under natural logarithm. Second one, power formula. Third one, natural logarithm. So if we try to integrate this one, this should be negative open quantity, natural logarithm of x, plus power formula, x to the minus 1 over minus 1, plus, again, natural logarithm of x plus 1 plus c. Then we try to combine this one. This is minus, this is plus, under one natural logarithm sign. So the final answer will be the natural logarithm, this is plus, right? So it will be in the numerator, x plus 1. This is a negative natural logarithm of x, this will be under the denominator. Actually, 1 under natural logarithm, x plus 1 over x, minus. We bring this negative exponent down, but this is negative, so this is negative 1 over x plus c. Final answer. Okay, I will repeat the final answer. The final answer is the natural logarithm of x plus 1 over x minus 1 over x plus c. Okay guys, that is integration using partial fraction under case number 2, repeated linear factors. Okay? It's easy. Good afternoon, Los Angeles.